So hi everybody, my name is TJ, part of the National CAP. This is the second workshop that I'm doing. We're going to be looking at artificial intelligence and big data specifically. So any questions, just feel free to ask at any time or put it in the chat. I'll try to answer it when I can. So what is AI? AI is a very hot topic today. They are smart machines, essentially. These are computer systems that are capable of making decisions that simulate human intelligence. They involve a lot of predictive modeling, classification algorithms, things like autofill, facial recognition, your Facebook friend recommendation, Netflix recommendation, self-driving cars, etc. These are all examples of how AI is used in our world today. And I think that as we continue to progress and develop in the digital age, AI is just going to become more and more prevalent. It can be a force for good. In fact, most situations, it is used for good things. But like all things in life, they have capacity for both good and bad. But I think for better or worse, AI is here to stay with us. Let's first look at the different types of AI. There's a misconception that AI is like the Terminator robot, which to be accurate, it is a form of AI, but that's what we call strong AI. So there's weak AI, there's strong AI. Most of the artificial intelligence that exists in the world today are examples of weak AI, right? So just like data modeling, the deep learning system, your neural networks, these are all weak AI. The difference is that they are not capable of making their own decisions. Their actions and their choices must be pre-programmed by a human, usually a data scientist. So how this model is going to be used, how it's going to work, the parameters that you use to tune the model and stuff, these are all done by data scientists. And that's why we consider them to be weak. On the other side, strong AI is what we consider to be experimental. Even the most advanced AI that we have now barely scratches the definition of strong AI. So probably the strongest version of like AI that we have is like probably the experimental version of self-driving cars. And these things, to be really accurate, are not actually classified as strong AI because to a large extent, it has to be pre-programmed by a data scientist. It's only the on-the-ground decision-making that is made by the AI itself. So by and large, strong AI does not yet exist in today's society. The definition of it is that these AI have the capacity for self-awareness, have thought and independent decision-making. So when we talk about Terminator Skynet, that is an example of strong AI, or like the Terminator itself. So that's what strong AI is. Like 99% of the AI that exists in this world today is considered weak AI. There are 4 different types of AI. The reactive machines, limited memory. Then on the other side, strong AI, we have the theory of mind, and we have self-aware or like self-aware AI. So reactive machines is basically where it's like the conventional classic definition of AI. You have a set of data, the data model is trained on the training set, and then it's then used to predict future decisions. So like IBM's Deep Blue machine, the one that beat Garry Kasparov, the world champion in chess at the time, that's an example of reactive machines. So AI has advanced a bit. Most AI nowadays use some degree of limited memory. This is basically where the deep learning system has a feedback mechanism. So that allows the model to retain and include information about the most recent decisions and the outcomes of that. So this information is fed back into the system through the feedback mechanism and then use the optimized future evaluations. So things like Google's AlphaGo, instead of just considering the board and the position as it is now, AlphaGo also considers the past few moves made by the opposing player, made by themselves, and can use that to weight the decision-making or the likelihood of certain choices being made in the future. And that's how it works. Like limited memory AI is like the LSTM machines, long short-term memory, or like generative adversarial networks. These are all examples of AI that use some degree of limited memory of past actions. On the other side, we have strong AI. The first type is theory of mind. This is basically AI that is capable of mimicking the complexities of the human mind. For instance, understand emotions, have creative ability so that they can write their own essays, their own articles and stuff. Like if you've seen material that's created by AI now, it's like yeah, it's like that. Okay, so if AI as it exists now does not yet have the capacity to produce things creatively. At most, what they can do is to replicate things or to like predict things using existing data set. They can't create new things as of yet. The last thing is last type of AI that is self-aware. There's basically AI that has a degree of consciousness. So consciousness is the awareness that you exist, right? So if you want something, like let's say you're thirsty, you want to drink water, you could just want that water and blindly seek out water. But if you are aware of the fact that you desire water, then you can use that awareness to sort of choose the best way to find water, for instance. So that consciousness or self-awareness, the fact that you are aware of your surroundings and that you are aware that you exist, allows you to process things on the meta level, but also allows you to represent yourself. And once AI achieves a degree of sentience and degree of awareness, that is when they're most likely to become indistinguishable from humans. So yeah, for better or for worse, this is what AI is. I think that the likelihood of AI achieving this level of sentience probably not going to happen in the foreseeable future, like 50 to 100 years from now. After that, maybe it could happen. I have no idea. But this is what it is. Okay, so let's first walk through like the mechanics of how AI works, like the foundational stuff about big data training and testing. So the foundation of all AI system, all self-learning algorithms and stuff, is that there is a training phase and a testing phase. The system is fed in a large amount of data. It's usually measured in terabytes and petabytes. To give you a concept of what that is, YouTube gets close to 1 petabyte of data uploaded every day. So the amount of data that exists on YouTube, how many petabytes it has, that is the kind of data, the quantity of data that we're talking about here. What happens then? You feed the entire data set into the model. The model is fitted onto the data. It might be hypertuned by data scientists or have feedback mechanisms to revise and update the weight. So like neural networks, for example, there's a black box and a lot of hidden connections between the things. When decisions are made, the outcomes of those decisions are assessed, whether those are good, whether they are bad, for example, and they're used to feedback to update the weights to optimize decision making for the future. The model is then used to predict decisions based on probability. So let's start with a very, very simple data model. You have a question, should you go out to play, right? Or go out of your house rather. The choice is influenced by 3 factors alone. The first is the weather. Second is whether you've done your homework. And the third is how your mother is feeling at a particular point in time. Okay, probably the most influential factor here. Okay, these are a data set of 6, right? 1, 2, 3, 4, 5. Yep. I give you 6 data sets. If the weather is windy, your homework is not done, and your mother is angry, the outcome is you stay inside, right? If the weather is sunny, your homework is not done, your mother is not angry, you go outside and play. Why? Because you are lazy AF, that's why. If the weather is raining, if your homework is not done, and your mother is not angry, you stay inside. Okay? If you're windy, weather is windy, homework is done, your mother is angry, you stay inside, like so on and so forth. You can see how it works. So basically, what we can see here from the data set that we are given is that most of the time you probably will be staying inside, you won't be going out to play. But given a set of circumstances or a set of conditions, you would then be allowed to go out to play. And that's what we want to use to predict. So if I give you this condition, right, the weather is windy, your homework is done, mother is not angry, do you go out and play or not? So that's what the model is created to solve. For this, we're just going to do a bit of mathematics. Use the naive Bayesian classifier, which basically uses probability to determine the most likely outcome. And while naive Bayesian uses the conditional probability of the Bayes algorithm, all AI prediction algorithm is based on some degree of probability calculations. So while the algorithm may not necessarily be the same and the formula may not necessarily be the same, all of them are based on the same foundation that you use probability to predict what is most likely to happen, especially when you have to choose between 2 choices. So the naive Bayesian classifier is built on conditional probability. So this idea, Px given A, B, and C, where X is the outcome, A, B, C are variables. So it's the probability of X happening given condition A, condition B, and condition C. Okay, let's do some maths. Conditional probability is the probability of event B happening given event A has already happened. It can be calculated from the individual probabilities and assumes that A and B are events that occur independent of each other, right? So the formula is probability of B given A is basically the same of the probability of A and B, or A intersect B, divided by the probability of A. The maths is not that important, but I need this to explain how it works. Let's say that you have the probability of breaking at a debate tournament is 0.3, right? Because only 30% of teams break at a tournament, supposedly. The probability of getting an AI motion and breaking is 25, right? So assuming you break, so assuming you have broken at a tournament, what is the likelihood of you getting an AI motion? That's what we're here to calculate. So probability of getting AI motion given you have broken, which is P of AI given break, is the probability of AI times the probability of break divided by the probability of break, which in this case is going to be 0.25 divided by 0.3, which you get the likelihood of 0.83. How do you interpret this? For four out of every 5 tournaments that you join, you will get an AI motion in the out rounds. And for the other one, you will not. The conclusion of this basically is we should start reading about AI because the likelihood of getting AI is very high. And this calculation here is obviously based on these two probabilities at the start. I've just invented random numbers for the sake of exposition. But the point is that given you're able to calculate these things, you are then able to derive the conditional probability of a certain outcome happening. So coming back to the example that we're using here, given the weather is windy, homework is done, and mother is not angry, the probability of going out to play is 2/6 because in 2 of the 6 scenarios, you go out to play. The probability of staying in is 4/6, which is in 4 of the 6 scenarios given, you stay in, right? So the probability of going out to play, given it is windy, homework is done, mother is not angry, represented by M prime, is this lah. So you calculate everything. These are all the probabilities of things occurring in the table. So in 2 out of the 6 examples, it is windy. 3 out of the 6 examples, there is homework, and 3 out of the 6 examples, the mother is not angry, creating the conditional probability of 0.25. The converse, which is that the probability of you staying in, given the 3 conditions, it is the exact same calculations, but it is divided by 4/6 instead, which gets the probability of 0.125. So what this means basically is that given you're able to calculate the probability of this thing happening and this thing happening, you can then decide what is more likely to happen, more likely to be true, based on this mathematical calculation. Okay, and because the probability of going out to play is higher than the probability of staying in, the model would then predict go out to play. And intuitively, I think that if you look at the data in question, if the weather is windy, you've done your homework and your mom is not upset with you, you probably will go out to play as well. So intuitively, the model has predicted the correct answer. I would just note that even though the probability of going out to play is higher than the probability of staying in, the probability of staying in is not 0. That means that it's possible in the data set given that given this same set of conditions, the actor or whoever this person is might choose to stay in and not go out to play. So it's not impossible. But what AI does is that they're able to calculate things on the basis of probability, what is more likely to be true given a particular set of conditions and circumstances. All right. The last thing to note here is about weighting of variables. So the basic naive Bayesian predictor assumes that all variables are independent and equally important, which in reality is not true. And also we only have 3 variables here, whereas advanced data modeling set can have up to like thousands of different variables. So not all of these variables are equally important. Some variables have a greater influence on the outcome. Some variables are just not like impactful on the outcome whatsoever. And that's why the model has to adjust for this thing to give the variables that are more influential on the outcome a greater weight. So what does it look like basically? Like the weighted naive variation predictor. The probability of X of given A, B, and C, you multiply the weight of A against the probability of A, and then you do that for all the things before you divide it by that. The weights can be calculated from information gain, how much one variable affects the outcome. There's a formula to calculate this, but we're not going to go through that today. All of these things improve the accuracy of the predictor. And when you create the training set or fit the model onto the training set, it's usually not enough to do it once. You have to do it again and again and again and again. And each time you take into account the data that was, or the model that was created prior to that, and use that information to hypertune the next model that you create before it even becomes functional. Yeah, I hope that's clear. Let's look at using AI to predict the outcome of the election or the likelihood of one person voting one way or another. Let us say I give you a set of attributes about a voter, and I ask you to predict whether this voter is likely to vote Democrat, Republican. You can also consider independent or not coming out to vote at all. But just for the sake of simplicity, I've removed those two conditions from the outcome. So I have here a data set from kaggle.com. It's a US voter survey, right? All of this information is publicly available, by the way. So you can see here, you have the voter or like the participant ID, their resident, the zip code, whether they registered, whether they voted, how they voted, whether they regret voting, whether they're confident in it, whether they support Obama, like this, that, like there's a whole bunch of different criteria. This was actually one or part of my final year project at Monash. So I actually have the entire model. I think I still have it. But anyways, the attributes that's captured by the voters, there were, I think there's more than 144. I limited it down to 144 because these were the most important variables. So they include the zip code or the location of the voter, the method through which they vote, their race, their age, religion, income level, gender, approval of Obama, their stance on LGBT rights, stance on abortion, stance on immigration, BLM, police, wars, truth, healthcare, climate change, taxes, poverty, and a whole bunch of other things. So these are all the different variables that we're going to factor in when predicting how one person is going to vote. How likely are they to vote for one party over the other? Okay, before we look at that, just need to talk about evaluating data models. So you have here is basically a confusion matrix, right? So after you train the data or you train the model on the training set of data, you need to test the model and assess like whether it's working or not. And to do that, you have a different set of the training data or testing data rather. In fact, you can take the data set and you can split it into 70% training, 30% testing, like however you want it to do it repeatedly to get the best outcome. We have here the predicted positive and negative and the actual positive and negative. If it is actually positive and the model predicts it to be positive, this is a true positive. If not, it's going to be a false positive. Same thing, if it is negative and it's predicted to be negative, that's a true negative. It's not. If not, it's going to be a false negative. So there are three metrics here. The most common one is probably accuracy. That's like the most intuitive one. But sometimes it is better to prioritize precision or recall. Accuracy is basically the proportion of clusters that is correctly identified. So you just take true positives, true negative, divide it by the total amount of data. That's like to get a percentage. Precision is the proportion of positives correctly identified. This is when identifying false negatives is less important than identifying correct positives. So that's when you want to use precision. It's just true positive divided by TP plus FP. Recall is the proportion of actual positive correctly identified. So true positive over TP plus FN or false negatives. So that's how we evaluate data models. But for purposes here, let's just look at accuracy. The naive Bayesian classifier results for the model of the voters that I did earlier, an accuracy of 69.1%, precision of 69.05%, and a recall of 69.1%. So overall, it is more than 50%, which means that the model is better than random guessing. But probably can still be improved significantly, especially if you want to use the results of this modeling for commercial purposes, so actual functional purposes in society. You're going to need something a bit higher than 70% accuracy here. But what this also means is that it reflects there's a lot of noise in the data set. So there's a lot of very contradicting information of people having the same attribute, but choosing to vote in different ways. That's example of noise in the data set. And the naive Bayesian classifier specifically is quite vulnerable to noisy data. So that's why the accuracy reduced. I used a bunch of different data modeling. The Python Keras neural network could achieve up to 95% accuracy if I hyper-tune the correct parameters. But it does show the ability or the accuracy through which these models are able to work and predict the outcome of people voting based on a given set of attributes. All right, I hope that's clear. Why is this important or valuable in this world? So when it comes to predicting how people will vote, like clearly that is of interest to political campaigns and people who are running for election and trying to get voted in. So if you're a politician or if you are a campaign manager, you want to maximize the chances of winning the election. And that's why the metadata that is gleaned from such big data analysis can help you do that. And I'll just note that for this example, the data given was entirely publicly accessible. It should still be publicly accessible if I'm not wrong. And so anyone can access the data and create the same model that I created earlier. So for instance, the information that you might want to ask, where are voters most likely to vote for you? Are there sufficient voters there to secure the election for you? So if that's the case and you've already secured a state, like it's more likely than not that most people in that state would vote for you, you probably would not want to focus campaigning there. Like red states, for example, if they're already predominantly red, as the Republican Party, you probably don't want to spend too much time campaigning there. I do point out the same thing is true as well. If most voters are just not likely to vote for you at all, in like predominantly blue states, for example, as a red politician, it's probably not really worth your time to campaign there because the likelihood of you being able to change and convince some voters to vote for you is probably not going to be worth the amount of time. And therefore, where you should spend most of your time campaigning are in swing states or a very close run election. These are where there's a lot of swing voters, or where it's very difficult to predict the outcome of that election. And that's why swing states are usually instrumental in determining the outcome of like elections on the national level, especially. And that's also where political campaigns focus the majority of their campaigning. Like that's one thing you could ask. Second, where are voters most likely to be influenced? What are voters most likely to be influenced by? You can look to the weights associated with each attribute/characteristic. You can then include it in speeches and campaigns. So for instance, if the voters in a particular region or a particular constituency are very affected by religion, for instance, then the way that you want to campaign to those voters is to touch on religious values that you may hold. Like, I don't know, I'm a church-going family man. That's where you should vote for me. And because if most people like resonate with the values that you hold, they want to vote for someone who is a church-going family man, you are more likely to secure that particular vote and that particular constituency. Same thing, you can use like income bracket, like race, your stance on police brutality, for instance. These are again more likely to be in poorer minority neighborhoods that care about these issues. When politicians go to campaign within those areas, they are likely to talk about these things or include them within their campaigns because it is most likely to influence voters to vote for them. And while for some of these things, you don't necessarily need big data analysis to get it, I think that what big data does is that it allows you to assess those multitude of variables, like 144 of those variables, with a far higher degree of accuracy, far higher degree of certainty, but also it allows you to glean data that you just would not be able to come up with on your own, unless you have like years or decades of experience that you're able to recognize things intuitively. AI just lets you do that so much easier. All right. Before we go on, let's just talk a bit about data skew, which is one of the problems with AI and the way it is trained. So basically, if the data model is is trained on the data set, if you control the data set fed into the predictors, data scientists can theoretically predict the outcome of the prediction. So bad data sets, they are not representatives of majority. Computers are not like intelligence, as much as we call them artificial intelligence. The artificial means not real, which would suggest that for most computer systems, you get garbage in, garbage out. If you feed garbage into the system, then your model that comes out is not going to be accurate. So if you want to skew the data, you can conduct the voter survey only within certain states. That is going to skew the results significantly in terms of identifying what most voters want. You only have the data or the results from those few states. It's not very accurate as a result for that. So how do we correct for data skew? The first thing, like there's a few ways to do it. The first way is to increase the size of the data set. The more data that's included, the more likely it is to be representative. Deep learning algorithms are advanced enough to determine weightages, so the proportion of data included is less relevant. So for instance, if we talk about like issues that affect people of a certain race, for instance, and we have a lot of instances or a lot of like things that occurs towards white people specifically, even though the majority of data surrounds these things is fed in, and the minority of data is fed into the system surrounds events happening to minorities or like people of color, for instance, the deep learning algorithm is smart enough to identify and to classify them based on their race. So it does not matter the proportion of the data fed in, so long that data is fed into the system, it is able to then attribute that in the modeling and include it basically. But regardless, the more data you have, the better it is. And like, I mean, it needs to be like statistically significant. It cannot be like one singular outlier. If not, the model might not account for it. But if it is significant, the model is able to factor in the differences and account for that. The second thing is like through transparency and accountability. So when you conduct research using AI, independent think tanks and research organizations, a lot of them are legally required to review the metadata, the data collection, and the pruning methodology. So how the model is created, how they arrive at these results, especially if they're making policy recommendations, it is required for them to be transparent about this so that other data scientists can have a look at it, especially and while all data science is probably not going to be perfect, it's possible, in fact, it's quite easy to see when researchers are intentionally trying to skew data in a certain way to achieve a particular outcome, like a particular conclusion. It might even be predetermined conclusions. But the point here is that revealing the methodology and revealing the metadata would shine a light on these things and disincentivize people from skewing data for their benefit. The third thing is just that data science has quite strong ethical standards, like most other industries, scientific industries out there. Data scientists are aware of problems of skew and misrepresentation, and so they develop means to correct for it, standardized steps for data collection, for example, make sure that the sample sizes, the sample data is representative, and make sure they have sufficient diversity in order to balance things out. So ethical standards exist. Doesn't mean that all data scientists are going to be ethical, but it does mean that those that aren't will feel very guilty about themselves. And the fourth way is to democratize access to information. So most deep learning libraries are available for free online. All of the libraries that I used to create my project, they're all freely available. You can just install them from the Python website. Many different organizations can run independent research on very similar accessible public database. If the conclusions reached are similar, this proves accuracy through the scientific method. And if it doesn't, then maybe there's something wrong with one or both of the surveys conducted, but also means that those scientists just need to revise their methodologies, identify the problem, and then potentially create or discover what's actually happening there. Examples for this include the OpenAI project. It's I think it's a free GitHub repository, if I'm not wrong, where there's a large number of deep learning projects that are publicly accessible here. If you play Dota, it's quite well known that the OpenAI was able to beat one of the best players, Dota players in the world. And they basically did that by training the AI on like millions of hours of games played at the professional level, where the AI was essentially able to teach itself how to play and then use that skills to beat humans who are prone to error sometimes. All right, cool. The last part about these things is where we're going to look at data privacy, which is a huge concern with regards to AI and big data, because the way that you source the data that you use to include in the training algorithm is quite important, because to a large extent, data that is going to be meaningful is also personal and unique to the individual and requires certain steps to be taken if you want to process it or acquire it in the first place. So big data management system, they source their value and accuracy from the volume of data collected. It requires them to obtain consent from users, but more importantly, to handle the data in a way that is careful and not going to leak out to other people that should not get access towards it. With regard to data privacy, legislation in most places require companies and organizations to disclose, number one, exactly what data is collected from users and for what purpose they're using that data. Second is that it allows users to request their personal data to be deleted from the organization's storage, and that must be complied with within a set time frame. So most of the apps that you have, if you go to the settings, there should be an option for you to delete your personal data, and that option is legally required to exist in the app. So if you want to leave the app, if you think that the app's being dodgy for any reasons, you click on that. The company is legally required to comply with a request to have your private data deleted. Thirdly, it just prevents the unauthorized sale / transfer of personal data without prior consent from users. So clearly, if the company says they're going to use this data for this purpose, then it is just like unfair for them to, or like it's just bad faith for them to transfer the data to a third party to try to sell it or to profit off it, basically in other ways. But the fourth thing is that it imposes a very clear legal duties on companies to protect the personal data of their customers, i.e. companies are legally liable for data breaches and hacks. So they can't say that they, didn't know this could happen or this wasn't their fault. It is the responsibility of the company to develop proper security features like firewalls, for instance, to ensure the protection of data. And while these steps might not be concrete, in most cases where data breaches do happen, it is often because there's no protection at all, as opposed to hackers being able to overcome firewalls because the cost of doing that is like quite high and you might not always be successful. So again, incentivize companies to develop those things, import like antivirus, firewalls, and all that crap. Where in the status quo, without these laws, actually not really status quo anymore, but like previously without these laws, they didn't really have that big of an incentive to do things like that. Data protection and privacy laws, they are a relatively new phenomenon, primarily triggered by the Cambridge Analytica scandal that we're going to look at in a bit. More than 75% of nations around the world have created / drafted data privacy laws for the first time. I say the first time here regarding online data and the internet because most countries have had privacy laws prior to this, but they have not been updated to reflect the digital age. All of these things have happened in the past 10 years or so it's still relatively new from a legal perspective. Yeah, didn't happen before that. In Malaysia, it's the Personal Data Protection Act 2010, PDPA, and all its subsidiary legislation in Malaysia. The EU General Data Protection Regulation, GDPR, is a legislation that was passed and came into effect in 2018, if I'm not wrong. It's a law that requires all companies that seek to sell goods or services within the EU to comply with the law, to disclose the way that personal data is being used, to ensure that the private data is protected, and ensure that if users request for their private data to be deleted, companies are required to comply with it. If they don't comply with it, they can be fined very severely, or they could be like booted out of the European market altogether. The EU is a lot stronger on data privacy and consumer protection than the US. I mean, honestly, the EU is like better in a lot of things than the US, but like this is one of those things. The US so far, even though they've been subject to a lot of different privacy breaches across the past years, still is one of the nations that is lagging behind in terms of creating proper data privacy legislation to protect consumers. All right, I hope that's clear. Let's look at Cambridge Analytica. So if you don't know about this, well, I wonder where you've been. Basically, Cambridge Analytica was a data analytics company that was working with Donald Trump's election campaign team as well as the Brexit campaign. Both of them were successful, which suggests data analytics is quite powerful. It's a company that's was owned by hedge fund manager Robert Mercer. A whistleblower leak revealed that data harvested from over 50 million Facebook users, often without their prior authorization, consent, or even knowledge, was used to create personality profiles around these users about the individual American voter. And then they use this information to target very specific political advertisements at them. So the fact that it's basically the project that I did just on a far grander scale and with a lot more information and a lot more personal data. They are able to identify meta trends happening in society, what's most likely to be the hot issues, the issues or the question that will be the tipping point in elections, for example. And they were able to build the model because they got access to us information. The data was collected through an app called This Is Your Digital Life. It was built by the academic Alexander Kogan separately from his work at Cambridge University. So he was a professor at Cambridge and he did this. His company, Global Science Research, GSR, in collaboration with Cambridge Analytica, hundreds of thousands of users were paid to take a personality test and agreed to have the data collected for academic use. The app also collected information of the test takers' Facebook friends, leading to accumulation of a data pool tens of millions strong. The reason they were able to do this back in 2010, I think, was because Facebook's platform policy allowed only collection of friends' data to improve user experience in the app, and they barred it from being sold or used for advertising. So basically, before all the privacy changes that Facebook was forced to implement, if you consented to share your personal info about your Facebook profile with someone, with an organization, for instance, that organization could not just harvest your personal information, but could also harvest the personal information of your friends. And this was allowed in order for companies and organizations to improve their, like basically to improve their services. They are not supposed to sell it to others. But again, given there's very little enforcement of these laws, these things just happen and they went on. And Facebook, the whistleblower suggests that the Facebook Exco, the executive officers, they were aware of it, but decided not to do anything. Whether they were or not, we won't, I guess we won't know, but the point is that it did happen. Yeah. Aside from this thing here about the app, something about digital life. Yeah, This Is Your Digital Life. Cambridge Analytica was also rumored to have partnered up with Pandemir. That's a, I think, US-based spy company, but I don't think that officially worked out in a partnership. But I do think that there was some collaboration that allowed Facebook or that allowed CA to build psycho personality profiles of the people from whom they collected data, and then use that data to influence the election in certain ways, negative ways. All right. The scandals surrounding Cambridge Analytica play to discussions surrounding data privacy directly at the forefront of the public consciousness. And what Facebook did was that they immediately revamped its internal data privacy policies that they had to because of the massive public backlash. They forced all users to read and accept the revised privacy terms and conditions. They restricted access to data from third-party apps. So in order for third-party application to access your personal data, you need to explicitly consent to it. Like, Candy Crush, for example, you want to log in with Facebook, they will bring you to Facebook, and Facebook will say that this app is taking your information. Are you okay with that? And then if you press okay, then the info will be released to Candy Crush. If you don't say okay, then the info is not released, and then you can just play the game without logging in on your account. Right. Mark Zuckerberg was also called to testify before Congress on the mishandling of user data. Although US lawmakers were clearly not very well equipped to legislate the online realm. It inspired the creation and drafting of data privacy legislation all around the world and the enforcement of existing data privacy laws, most of which does not apply to the online storage of data. So Mark Zuckerberg's interview at Congress, quite interesting, mainly because most senators and lawmakers at the time were not very tech savvy, so they didn't really understand, or yeah, they didn't really understand how Facebook works. And therefore, yeah, they asked very strange questions that we're going to see right now. Right, I think I should share my audio. Okay.
Well, how do you sustain a business model in which users don't pay for your service?
Senator, we run ads.
If I'm emailing within WhatsApp, does that ever inform your advertisers?
No, we don't see any of the content in WhatsApp. It's fully encrypted.
Right, but is there some algorithm that spits out some information to your ad platform? And then let's say I'm emailing about Black Panther within WhatsApp. Do I get a Black Panther banner ad?
Senator, Facebook systems do not see the content of messages being transferred over WhatsApp.
Yeah, I know, but that's not what I'm asking. I'm asking about whether these systems talk to each other without a human being touching it.
Senator, I think the answer to your specific question is if you message someone about Black Panther on WhatsApp, it would not inform any ads.
Okay.
There have been reports that Facebook can track a user's internet browsing activity even after that user has logged off of the Facebook platform. Can you confirm whether or not this is true?
Senator, I want to make sure I get this accurate, so it would probably be better to have my team follow up.
So you don't know?
I know that people use cookies on the internet, and that you can probably correlate activity between sessions. We do that for a number of reasons, including security and including measuring ads to make sure that the ad experiences are the most effective, which of course people can opt out of.
Will Facebook offer to all of its users a blanket opt-in to share their privacy data with any third-party users?
Congresswoman, yes, that's how our platform works. You have to opt in to sign into any app before you use it.
Could somebody call you up and say, I want to see John Kennedy's file?
Absolutely not.
Could you, if not, could you, not would you do it, could you do it?
In theory.
Do you have the right to put my data, a name on my data, and share it with somebody?
I do not believe we have the right to do that.
Do you have the ability?
Senator, the data is in the system, so...
Do you have the ability?
Technically, I think someone could do that, but that would be a massive breach. So we would never do that.
It would be a breach. Thank you, Mr. Chairman.
Thank you, Senator Kennedy. Senator Baldwin's up.
All right. So that is Mark testifying before Congress. So I think that these are probably the more entertaining parts of the interview, but there are some quite serious parts, and the fact that lawmakers weren't really capable of legislating things, especially at that particular point in time, is a pretty significant concern. Although I would say that since this happened quite some time ago, there's been a lot of positive change that has happened, and a lot of data privacy legislation created by people that actually understand what is going on that has been passed since then. So regardless, our data are still better off.
Oh,
God. Okay, the next thing we'll talk about here is about the freemium model. So the ad space model of social media companies basically what allows them to keep the platform free and accessible to everyone. So it is not, you are not paying for the product, or which is the social media platform. You are the product itself. Users are the product, and the data that they generate by using the platform, linking their profiles to millions of other third-party applications, all of this data is fed back into the system, where Facebook or Twitter, Instagram, YouTube, they use this information to create and generate a personality profile about who you are. Use that to recommend you do things, determine what pops up on your timeline, what shows up on your Instagram feed, etc. So companies generate personality profiles for each user. They then sell targeted advertisements, for instance, things that people are most likely to purchase based on your identity markers, your recent activities, whole bunch of other things that you may have done online. This requires them to increase access to as many users as possible in order to increase the accuracy of the modeling. So if you're a business, for example, like you sell shoes or like you sell t-shirts, like sell water bottles, if you purchase an ad from Facebook, Facebook will display those ads to the people most likely to buy your product because they have already classified your product into like a certain category, and they have already tags associated with groups of users that are likely to be open to purchasing those things. And what this does is that it just massively improves the efficacy of putting those ads out, because prior to this, you had to like either put in the classified section of the newspaper or to put huge ads up on billboards at the side of the road. And it just means that people that weren't really interested, things like, I don't know, makeup or high heels, will also exposed to those ads. Whereas in today's day and age, targeted advertisements means that people most likely to buy those things, or people who are most likely to need those things, are then exposed towards that. Improving, like, I guess it improves marketability, also improves user experience because they are actually exposed to things that they previously might not have been aware of. Which then begs the question, can users meaningfully consent to the usage or release of personal data? So, and I think that the answer to this is probably not really, because the ubiquity of social media as a medium of communication necessitates users to have an account and profiles on multiple different platforms to remain relevant to the digital age. It just means that even though you press the I consent button when you create a Gmail account or when you create a Facebook account, you did not really have the choice to opt out of Facebook or social media entirely. And that's why, even though you are clicking on the button that says I consent, whether that consent is actually meaningful is a subject of great question, of like great debate. So why is it important? Like small business that are built entirely on Facebook Marketplace and on Instagram, these are people that rely to a large extent on the platform for their livelihoods. Information/updates about the lives of your friends. It's a networking value. You want to know what's happening in your life. Like, you want to see what your friends are posting on Instagram, on Facebook, etc. Keep up with the things. Don't be like living under a rock. Thirdly, is like latest news around the world. From news site, from anyone that had interest in creating content, posting it up, yeah, you can get access to it. Whereas otherwise, you would have to go and look it up either on the internet or like read it on a newspaper or something. You can also post and create your own online profile, especially if you are a freelancer or you rely to a large extent on people seeking out your services. This requires you to create a profile that displays what you are capable of doing, what you have done before in the past, like proof that you're competent, for example, make yourself very relatable, very likable, and people are more likely to reach out to you, offer you opportunities. Whereas if there's no information about you online, if your Facebook profile is the blank guy's face, they can't even see your face, they don't know anything about you, they're just a lot less likely to want to reach out to you because they don't have any information at all. So it's for some industries and some lines of work, it is incredibly necessary and important for you to have a Facebook profile, not just Facebook profile, like any social media profile, like a LinkedIn profile or something, and then to curate that profile in a way that's like, attractive for recruiters. Lastly is memes. I'm not sure anyone here can imagine a life without memes on a daily basis. Yeah, okay, I think enough said. The second thing to note about social media is like addiction. So social media companies design the user interface in a way to be incredibly addictive in order to incentivize the increased use of the platform and increase engagement. So like the like feature is inspired by the dopamine rush, the brain's natural reward mechanism. So they've invested efforts or like into clinical studies, psychological studies to make Facebook more appealing to people. And one of the ways to do is by triggering the dopamine rush in your brain. Like you post a picture of yourself online and people like it, like a lot of people like it, you feel good about yourself, you feel popular, and that triggers the dopamine rush. And you crave more of that. And that's why you're more likely to post more things online and engage that. That's the addiction mechanism. The second way is like the fear of missing out. So that's why Facebook and other social medias that have very time-sensitive updates, like disappearing stories. You have to open your Instagram account every day because Insta stories disappear after 24 hours. Snapchat has stories that disappear in even less time sometimes. So if you don't open your social media, you just miss out. And because you have the fear of missing out, you will keep opening it and you keep scrolling and you keep scrolling and keep scrolling and oops, the day is all gone. So these are ways that the platform is gamified in order to make it incredibly addictive, but also means that people, especially kids and teens, find it difficult to opt out of using social media. I would note also that the mechanisms of engagement means that the information and the content that is most prioritized and pushed up to the top of the timeline is things that get the most engagement. So like that's how videos become viral essentially. They go viral because a lot of different people engage and interact with that content. And so the Facebook algorithm sees that that's something to be quite popular and they push it up to the timeline so that more people can engage with it, more people can know about it. That's another way that they make it very appealing. Right, so that's for data privacy, for Facebook rather. The next thing we'll look at, or the next example is like Face app, which was launched in 2017, developed by Wires Lab, a company based in St. Petersburg in Russia. Its chief executive officer, Yaroslav Goncharov, used to be an executive at Yandex, widely known as Russia's Google. So there's concerns over data privacy and whether the Russian government has access to the facial recognition data and could be used to track locations. Many people, especially in the US, continued to use the app anyways, even though this information was made public to people there. Like, aside from this particular instance of Face app, there's also general concerns of authoritarian states getting access to big data analysis because of the capacity for them to use the information or the personal data of people, use it to generate personality profile. In China, for instance, it has been rumored for the CCP to create personality profiles to identify potential dissidents even before they even become dissidents in the first place. So they can keep an eye on them and before basically get ahead of any potential revolutions happening in the country. So while big data is itself a tool, it has capacity for both good and evil, depends to a large extent on the actor who is using that and the end goals of the usage of that technology. Last thing, deepfakes. Using image processing AI to seamlessly blend and merge the faces of public figures, politicians, celebrities, etc., onto video and audio that they're not actually in. So it's basically it's basically Photoshop, but on a whole different level. The reason why it's potentially damaging is because the images seem very, very real and can be used to place the public or the faces of public figures or public figures in situations that they'd rather not be portrayed in. It's been used to generate nudes or sex scandals that have ensnared politicians. So you release like a sex video and then you like Photoshop or you deepfake the politician's face onto one of the people there. And then suddenly that's a huge scandal. And then even if the video is not true, the damage is done towards your political reputation. More often than not, will have a pretty big impact. So as AI continues to improve, it's getting harder and harder to detect AI-generated deepfakes from real imagery. So there are very strong concerns about dismissing potentially compelling evidence on the basis that it could be fake. So it's basically the converse. So on one hand, if you're not able to tell the difference, then if you see a politician in a sex video, for example, then you could think they're a bad person. But the converse is also true. If it is impossible to tell the difference between a real video and a fake video, then it is possible for the politician or the public figure in question to deny the fact that they were in the video, to say that it was probably like created through deepfake AI. And while it probably is not going to restore their public reputation, it can be used as a defense in criminal court, that because it is impossible to distinguish, there's an element of reasonable doubt. And that's why this evidence is insufficient to convict someone. It's a legit issue. Just to show you what I mean, let's watch Jon Snow give us the ending we deserve.
It's time for some apologies. I'm sorry we wasted your time. I'm sorry we didn't learn anything from the ending of Lost. I have more lines in this video than I had in the last season. I'm sorry for that. And I know nothing made sense at the end. When the Starbucks cup is the smallest mistake, you know you fucked up. We take the blame. I'm sorry we wrote this in like 6 days or something. Now, let's burn the script of season 8 and just forget it forever. Fuck season 8.
Yeah. I hope anyone who is a Game of Thrones fan here can relate. Okay, so this should conclude the workshop regarding AI and big data. If anyone have questions, feel free to ask. I will try to answer them. Okay, people are asking for the slides. And yes, I will give you the slides. So don't worry. Just now, so okay, someone asked a question. Just now I mentioned that strong AI and weak AI, whether Sophia the robot is considered a strong AI. Who is Sophia the robot? Sophia is a social humanoid robot developed by Hong Kong-based company Hanson Robotics. Sophia was activated on February 14, 2016, made her first public appearance at South by Southwest Festival in mid-March 2016. Sophia became a Saudi Arabian citizen, first robot to receive citizenship of any country. I have no clue. Oh, so it says that there are cameras in Sophia's eyes combined with computer algorithms that allow her to see. She can follow faces, sustain eye contact, and recognize individuals. She is able to process speech and have conversations using a natural language subsystem. Sophia has upgraded with functional legs and the ability to walk. CNBC has commented on Sophia's lifelike skin and her ability to emulate more than 60 facial expressions. I'm not sure about this. I don't think it will be classified under strong AI, because strong AI basically requires the AI to have sentience, to have self-awareness. And while Sophia is able to communicate or interact with other people, and I think have basic awareness about what's happening, I don't think this qualifies as sentience or self-awareness. So I probably would not qualify this as strong AI. But if there's, I mean, this is only based on what I'm reading about her, because I've not heard of this prior to this. So it's possible that there are other features that will qualify her as such, but I'm not aware of it. Okay. Any other questions? Okay, that doesn't seem to be the case. So I guess we can end it here. Thanks so much for coming to this workshop. I hope you found it helpful. And yeah, I'll see you at future things, I guess. Bye.